Hello everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of Intermediate First Year Maths A. We have started our discussion with matrices. From where did we start? We started with determinants. What was the determinant? How did we find the determinant? We learned different properties of determinants, right? And we did few problems on determinants using its row operations and column operations, right? Fine. Today, let us do few more problems on determinants of matrices. Okay, see here. On the same lines, there is a first question given. He is asking us to show that the determinant of y plus z x x y z plus x y z z x plus y is equal to 4x y z. Right? How to do? Any idea? I already told. If you want to directly do the determinant of that matrix, you can directly do. You will get the answer. But after using few elementary operations, it has to be done. Okay, how do we do? It's up to you whether you want to subtract it or it's okay. See here, if you observe here, if I add these both, that will be y plus z. If I subtract it from this, obviously I will get 1 0, right? Okay, do that operation first. R1 tends to R1 minus sum of R2 plus R3. Is it okay? See here, this will be y plus z minus y minus z, that will be 0. X minus z minus x minus z. X will be cancelled, minus z will be 2z. Is it fine? And the next x minus x will be cancelled, minus y will be minus 2y. The remaining things will be as it is. Is it right? Yes or no? Okay, now directly find the net. Plus, minus, plus. At least you got 1 0, right? That is the main objective. That will be minus of minus 2z into y into x plus y minus zy. Isn't it? Minus 2y into yz minus z into z plus x. Just simplify it. Minus into minus plus 2z. Here xy minus y square minus zy. Is it right? Minus 2y yz minus z square minus zx. Is it okay? Let us simplify each and everything. What do we get? 2xyz minus 2zy square minus 2z square y minus 2y square z minus 2z square y plus 2xyz. Is it fine? Now check here. Here minus into minus is plus 2z y into x plus y minus zy. Is it okay? Which means here yx plus y square, here it is plus, and then minus zy, here it is plus y square. Is it fine? Next here plus 2z square y. Now just check whether we can cancel something. 2zy square, 2zy square. Here 2z square y, 2z square y. 2xyz plus 2xyz. Answer is 4xyz. Is it right? Isn't it easy to solve? The only thing we have to remember is this first operation. Few people, they do like R2 minus R1, R3 minus R1. If you want, you can do. Okay, at least you will be left with z and y. Here you will be left with 1z. Here you will be left with 1 y. And here you will be left with z. Here you will have 1 more x. Here you will have 1 more x. Here you will be left with x, y. Is it clear? It's up to you. However you want to solve, you can solve. Is it clear? Shall we move on to the next problem? Let's do. Look at this question. The question given has 1a square a cube, 1b square b cube, 1c square c cube is equal to a minus b, b minus c, c minus a, ab plus bc plus ca. Right? Just check. I have 3 ones here. What to do? Just the popular 2 row operations, right? What are those? That is R2 tends to R2 minus R1, R3 tends to R3 minus R1. Is it fine? Just do that. That is 1a square a cube. 1 minus 1, 0. B square minus a square. B cube minus a cube. Here 0. C square minus a square. Here c cube minus a cube. Is it fine? The next. Hopefully you know what to do next. Tell me what to do now. Here 0 is as it is. B square minus a square can be written as b minus a into b plus a. Right? And here b cube minus a cube is b minus a into b square plus a square plus ab. Is it fine? Good. Is it clear? Did you understand? The next here 0. Here it is c minus a into c plus a. Here c minus a into c square plus ac plus what is it? A square. What is that we can take common here? Can I take b minus a common here and c minus a common in the third row? Yes, right. Just do that. B minus a, c minus a, if I take it as common, I will be left with 1 a square a cube, and the next 0 b plus a, b square plus a square plus ab, 0, here c plus a, here c square plus a square plus ac. What shall we do now? Can I take anything common here? No, right? So better we'll subtract these both. R2 tends to R2 minus R3. Let's see what do we get. See here, this will be b minus a, c minus a into 1 a square a cube will be as it is. Here 0. Here what do we get? A will get cancelled. I will get b minus c. Is it right? Here b square minus c square a square cancel. Here b square minus c square plus, if I take a common, I will get it as b minus c. Then 0 c plus a, c square plus a square plus bc. I mean ac. Is it right? Now what do we do? Let us take b minus c common from this. What do we get? 1 a square a cube, 0, 1. Here if I take b minus c common, what do I get? Here b minus c, then I will get it as b plus c plus 1. Here 0, c plus a, c square plus a square plus ac. Is it right? Now apply that from this side. What do I get? That will be b minus a, c minus a, b minus c into c square plus a square plus ac minus b plus c plus 1 into c plus a. Is it fine? Now we have to multiply and check whether we will get ab plus bc plus ca. And here it is b minus a, but I have a minus b in the question. So let us take interchange these both, because minus of this both will become plus. That will be a minus b, b minus c, c minus a into c square plus a square plus ac minus bc minus ab minus c square minus ac minus c minus a. We should get a square, right? Here there should be a. I have taken a common, right? Then I will be left with a here. Here also a. Then ac minus a square. Is it okay? Now just check. C square will get cancelled. A square will get cancelled. And the next, what are left? I should get ab plus bc plus ca. Here 1ac will get cancelled. I will be left with ab plus bc plus ca. Is it right? Here I have taken minus common. Then I get, if I multiply that to that, a minus b, b minus c, c minus a into bc plus ab plus ac. Is it clear? A bit confusing, but okay, you can do it. Is it clear? Shall we move on to the next problem? Let's do. Look at this question here. This is very important, and in this question we have to remember the properties of determinants. Just check here. There is a question given. What is it? A square 1 plus a cube, b square 1 plus b cube, c square 1 plus c cube is equal to 0 is the question, right? And he is telling that this particular part is not equal to 0, right? we'll use this condition somewhere after in the end of the sum. Then he is asking us to show that ABC is equal to -1. How to do? After seeing this, can you identify to which property does it belong? Tell me. Might be some seventh property, I think. We can segregate this into a square 1, b square 1, c square 1 into a square a cube, b square b cube, c square c cube, that is equal to 0. Is it right? Can we do like this? Just we have to segregate this part. Is it okay? This is here. Yes? Now we have to simplify this. What do we do in this is we'll keep this as it is and we'll take a common from this and b common from this and c from this. Okay? What do we get? 1a square. Sorry, here also 1b square. Here 1c square. That is equal to 0. That's it. Now we have to change this matrix as this. How to do? That is, we have to segregate. There is plus sign in between. Don't forget it. Okay. Now just interchange this. Okay. Column 2, column 3. Sorry, column 1. Let us interchange. Okay. That will be a square 1, b square 1, c square 1 plus abc into, I will get it as -1 inside. Hope you remember the property that if I interchange any two rows or any two columns, the determinant will become negative. That is abc 1 1 1 a square b square c square, that is equal to 0. Is it fine? And the next step, let us interchange these both. Let us interchange C3 and C2. Okay. What do we get then? This will be as it is a square 1, b square 1, c square 1 into abc into -1. Now if I interchange these both, again I will get one more negative term. Right? Then here will be abc. I have to interchange these both. That will be a square, b square, c square 1 1 1. That is equal to 0. Hope you can understand this. Clear? Now if you check, these both are same. Can I take this as common? A square 1, b square 1, c square 1. What is left? 1. What is left here? Plus ab c equal to 0. Right? What is the condition given? This is not at all equal to 0. Obviously, this term is equal to 0. That implies 1 plus ABC is equal to 0 since A square 1, B square 1 and C square 1 is not equal to 0. Fine. Just write it from this. I can write it as ABC is equal to -1. Is it clear? Is it not easy to solve? But the only thing we have to remember, this property. We have used two kind of properties. What is it? Segregating this part, and after that interchanging columns, we get always negative determinant. Is it clear? Fine. Shall we move on to the next problem? Let's do. Look at this next question here. He is telling to show that a square plus 2a, 2a plus 1, 1, 2a plus 1, a plus 2, 1, 3, 3, 1 is equal to a minus 1 whole cube. How to do this? Just fine. This is the same, the most popular row operation. What are those? R2 minus R1, R3 minus R1. Okay. Just check it here. Apply R2 tends to R2 minus R1, then R3 tends to R3 minus R1. Is it fine? Just do that. That will be a square plus 2a plus 2a plus 1, 1. Just subtract this. Okay. 2a will get cancelled. 1 minus a square. Either 2 minus 1 is 1, a minus 2a is minus a. 1 minus 1 is 0. Is it okay? And the next, this thing, 3 minus a square minus 2a. The next here, 3 minus 2a minus 1, that is 1, 2 minus that is 2 minus 2a. here 0. Is it fine? Did you understand everything? If you want, we can even change some kind of thing in between. Okay, once again I have did r2 minus r1 and r3 minus r1. Okay, that is 2a will get cancelled, 1 minus a square. Here 2 minus 1 is 1, a minus 2 is minus a, 1 minus 1 is again 0. And the next we'll take 1 minus a common here, then we'll check. It will be a square plus 2a plus 1, 1. Here it is 1 plus a, here 1, here 0. Here 3 minus a square minus 2a into 2 into, okay, 2 minus 2a, let us write. Now substitute det, plus minus plus. Now 1 minus a into 1 into this minus this, 1 plus a into 2 minus 2a minus 3 minus a square minus 2a. Just simplify it. Okay, what do we get here? 1 minus a into, here it is, let us multiply these all, 2 minus 2a plus 2a minus 2a square minus 3 plus a square plus 2a. Is it fine? Is it right? Once again let me check here. 2 minus 2a plus 2a minus 2a square. Is it right? Now see here. 1 minus a, here minus 2a square plus a square is minus a square, and the next let us add these all a's. 2a, only 1 2a, right? And the next 2 minus 3 is minus 1. Just take minus as common, you will get a square minus 2a plus 1, right? The next multiply with this minus 2, this will be a minus 1, and this is nothing but a minus 1 whole square, this will be a minus 1 whole cube, right? What is that we have done? We have used the popular row operations here, okay, and then we got this determinant and we could simplify to get the answer. Is it right? Shall we do one more problem? Let's do. Just look at these questions here. He is telling to show this is equal to 0. How to do? Tell me. Once just check here. If I add these three terms, what happens? Minus b plus b will get cancelled, cc will get cancelled, and a will get cancelled. Okay. Similarly, we'll get whole row as 0. That is r1 tends to r1 plus r2 plus r3. That is 0, 0, 0. B minus c, c minus a minus b. Here c minus a minus b, b minus c. Since one row is 0, obviously the whole determinant is 0. Is there anything to do? Nothing, right? Even if you write a plus minus plus plus into 0 into something, minus 0 into something, again plus 0 into something, however it is 0. Okay, see here, this is not w, this is omega. Actually it will be like this. Okay, you can refer to your textbook also. He is telling that 1 omega square are cube roots of unity. Then the condition is, remember this, if 1 omega square are cube roots of unity, then 1 plus omega square is equal to 0. This is one of the most important conditions which you have to remember. Actually, we will study about this in our second year, that is in year 2A. Till then, remember only this condition. Okay. We also know this one more thing, that is I square equal to minus 1. Okay. These both conditions we will study in the same chapter, that is complex numbers. Okay. Just look at here. What can we do now? Tell me. Again same thing. Add all row operations. R1 tends to R1 plus R2 plus R3. That will become 1 plus omega square, 1 plus omega square, 1 plus omega square. Here it is omega square 1, omega square 1 and omega. This is 0. Let us write that. 0, 0, 0. Omega square 1. Here omega square 1 and omega. Since one whole row is completely a 0, therefore this is 0. Is it right? Did you understand? Fine. These are all the different basic problems of determinants. Okay? Fine. Let us meet in the next session with the more problems of matrices.